reasons used in a proof can include definitions, properties, postulates, and theorems. So we've talked about everything except for theorems. A theorem is a statement that can be proven. So once you've proven a theorem, then you can use that theorem for a reason in any proof. So let's write some proofs. Example number 1 says, given that the measure of angle 1 is equal to the measure of angle 3, we need to prove that the measure of angle DBA is equal to the measure of angle EBC. So let's set up our proof. We get a line. Oops. Get that line again. And that's in a bad spot. All right. And we got some statements and some reasons. And the first thing we know is that the measure of angle 1 is equal to the measure of angle 3. And that is given. And we can clearly see it marked on our picture with these little marks that are already there. Eventually, we need to prove that DBA, so that's this angle, DBA, is equal to the measure of angle DBA is equal to the measure of angle EBC. And what we can see is that they both include angle number 2. So some kind of way we need to include angle number 2. So here's where your logic and your thinking has to come in about what you can do with that angle. So the next thing that I'm going to say is the measure of angle DBA is equal to, and remember that's the green one, the measure of angle 2 plus the measure of angle 3. And that is because of angle addition postulate. And I'm also going to say that the measure of angle EBC is equal to, and EBC is the blue one, the measure of angle 1 plus the measure of angle 2. And that is also because of angle addition postulate. So now I've introduced the two angles that I need to prove because I introduced them here and here, so they're in my proof now. But I know that the measure of angle 1 is equal to the measure of angle 3. So my next line, I'm going to say that the measure of angle DBA is equal to the measure of angle 2 plus the measure of angle 1. And so what I want you to notice is that I substituted angle 3 and angle 1 because they are equal. Okay? And so now when I look, I can see that the measure of angle EBC is equal to the measure of angle 1 plus the measure of angle 2, and the measure of angle DBA is equal to the measure of angle 2 plus the measure of angle 1. So I'm going to simply rewrite one of those. I'm going to say that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle EBC. And that is my symmetric property of equality. And when I look at those, then I can see that the measure of angle DBA is equal to the measure of angle 2 plus the measure of angle 1. The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle EBC. So I can say the measure of angle DBA is equal to the measure of angle EBC because of transitive property. And I'm done. Now, your thinking may have been different, but as long as you can logically get from the given to the proof and make it work and make it be logical, then you're okay. So let's try another one. I'm going to set it up. And this one says that given B is the midpoint of AC and C is the midpoint of BD, prove that AB is equal to CD. So let me get my statements together. Okay, and so then the first thing is B is the midpoint of AC and C is the midpoint of BD. And I know that if they're midpoints, first of all, I got to write that they're the given. But by definition, I know that if they're midpoints, if B is the midpoint of AC, then these two segments are congruent. And if C is the midpoint of BD, then these two segments are congruent. So that has to be my next statement. So my next statement says that segment AB is congruent to segment BC. And I can also say segment BC is congruent to segment CD. And both of these are definition of midpoint. Okay. And then at this point, I don't know anything about my properties of congruence, and I need to prove something about equal. So the next thing that I'm going to have to say is that the length of AB is equal to the length of BC. Oops, and that is not length. And that the length of BC is equal to the length of CD. And this is from the, I made some big mistakes. Let me fix this real quick. So when I'm talking about length, remember there's no bar. And then this is the definition of congruent segments. And then I can say that AB is equal to CD, because if AB is equal to BC and BC is equal to CD, then AB is equal to CD, and that is going to be my transitive property. And I'm done. Let's look at our card number 17 and our card number 18.